Hello everyone, welcome to MathPrax. In this video is an arithmetic progression problem with 3 questions in it. I am going to use it in order to demonstrate how to use the formula for this sequence on how to obtain the specific term given some condition. Here it goes. The 5th term of an arithmetic progression is 18 and the 12th term is 39. Find the first term a sub 1, the common difference d, the number of terms if the last term is 96. The main thing you need to know or recall, if you are already familiar with the arithmetic progression topic, is the formula or the rule that the sequence follows, which you can see right here, where the general term a sub n is equal to the first term a sub 1 plus the quantity of n minus 1 multiplied by the common difference d. You can think of this formula like this. How many times do I need to add the common difference to the first term in order to get to the nth term? Here are 2 examples. The one on the left has the common difference of 2 with 5 terms in the sequence, while the other has the common difference of 5 with 6 terms in the sequence. Looking at the first term here, how many times do I need to add 2 to it to get to the 4th term, which has a value of 7? The quantity here inside the parentheses answers that question. If we were asked for the 4th term, that means we need to add 3 times the common difference of 2 in order to get the value of 7. 1, 2, 3. On the other hand, in this example on the right, how many times do I need to add 5 to the first term, 10, in order to get the 6th term, which has a value of 35? Again, the quantity inside the parenthesis answers that question. We were asked for the 6th term, which means we would need to add 5 times the common difference of 5 in order to get to the general term 35, which is a sub 6 in this question. So let's go ahead and solve the problem. Number 1, find the first term, a sub 1. Let's have a look at what information we have. It was mentioned that the 5th term is 18. That gives us the a sub 5. The 12th term is 39. That gives us the a sub 12. We'll use the information here in the formula. First is the a sub 5. So a sub n gets a value of 18 equals a sub 1, which is unknown as of this moment, plus the quantity of n having a value of 5 minus 1 times the common difference d. Here we ended up with 2 unknowns in the equation. Now let's use the a sub 12. A sub n gets a value of 39 equals a sub 1 plus the quantity of n having a value of 12 minus 1 times the common difference d. With 2 unknowns and 2 equations, we can now finally solve for the first term, a sub 1. Let's eliminate the term d in the equation. For that, we'll rewrite both in terms of d. For the first equation, d equals 18 minus a sub 1 divided by 4. For equation number 2, d equals 39 minus a sub 1 divided by 11. Equating both expressions on the right side gives us the following equation, in which only a sub 1 is the unknown term. Let's go ahead and do cross multiplication here. 11 times 18 is 198, minus 11 a sub 1 equals 4 times 39 is 156, and then here, minus 4 a sub 1. Transposing negative 4 a sub 1 here goes there, and 198 here goes on the other side. This gives us negative 7 a sub 1 equals negative 42. And then, the answer to the first question in the problem is 6. That would be the first term in the progression. Now, going to the next question, let's move this to the side and clear up our solution space. So we are asked to find the common difference d. Since we now have the value for the a sub 1, we can use either of the equations here to solve for d. Here, I simply use the first one. That gives us 18 equals 6 plus 4d. Transposing 6 to the left side gives 12 equals 4d. And so the value for the common difference is 3. Second question answered. Let's put this to the side as well, and again clear up the solution space. Now we're ready to answer the last question. How many terms are there if the last term is 96? A very easy one. The corresponding n for the last term gives us the number of terms in the given progression. So a sub n here is 96 equals 6 for a sub 1, plus the quantity of n minus 1 times common difference of 3. Transposing 6 to the left side gives 90, and then divided by 3 here equals n minus 1. Solving for n gives 31. So there we have it. There are 31 terms from 6 to 96 having the common difference of 3. There are other approaches to solve this problem. When you get comfortable with arithmetic progressions and things get easier for you, you will be able to manipulate the formula where you don't have to always use the first term as the reference term. For example, this problem gave us the 5th and the 12th terms. If you rephrase the idea behind the formula into how many times do I have to add the common difference d to the 5th term in order to get to the 12th term? From that question, you will be able to directly solve for the common difference without having to use two equations. And from the result, you can ask yourself, how many times do I have to subtract the common difference from the 5th term in order to get to the first term? That will give you the a sub 1. We will use these techniques in another video. You will even be able to calculate mentally for some terms of the sequence in certain problems, and trust me, that is where the fun starts. If you already want to try it, here is a problem for you. Go ahead and hit pause if you feel challenged. Here are the answers. Thank you for watching, and if you found this video helpful, please hit that subscribe button so you don't miss out on my next tutorials. I'll see you in the next one.